Go ahead and save. Testing. Okay. All right, and then I'm gonna check attendance one more time, hit done. Okay, and let's go ahead and share the screen. So I'll check attendance again in about 10 minutes at 2:15. Let's see. So welcome, gentlemen. We're at the end of week, what is it, 6, right? So just as a reminder, at the end of week, 8? No, sorry. During week 8, exam 2 becomes available. So when I go to calculate your midterm grades, it'll be based on basically everything from the beginning up through exam 2. And the midterm grade, just as a reminder, all it is a snapshot of where you are at that moment in time. It has no bearing on your final grade whatsoever. It's just a, hey, up until this moment, based on what I see on my end, this is what it comes up to, right? As always, if you have questions or if anything is not clear, if you have questions about anything, now is the best time to ask. I still encourage you to email me, but I'm just going to be honest with you. I'm more than likely I'm not going to check my emails. It makes me anxious, so I just don't check it, and it'll be okay. So to offset that, since I know, I'm just not going to check emails. That's why, again, the original intent is for class time to be a Q&A session or a study session. So during class is the best time to ask me stuff. Still email me anyway, just so it's on file. But if you're really serious about getting your matter resolved, just ask me during class and I'll stop and we'll talk about it. I had a student in my 10 a.m. class. He said, I had a question about my exam 1. What I submitted was right, but the exam didn't give me credit for it. So right there on the spot, I went on to pull it up and sure enough, he was right. So I just gave him credit for it. So after I went through his exam, and it took me like a couple of seconds. After I went through his exam, it bumped him up by a letter grade. That way he didn't have to go and take it again. You see what I'm saying? So you definitely want to take advantage of class time. To me, it just didn't make sense to have office hours at another time for several reasons. But so that's one thing. Again, so exam 2 is coming up. Right after that, we're going to have spring break. We don't have that many more questions in this section. Before we get started, I actually want to do a poll. I want to do the same poll with you guys that I did with my students from earlier. Let me go ahead and launch this poll. And I'm really more so interested in your responses for question number 2. Number 1 is how we normally do. So I just started a poll in Zoom. So just check it out. Take a look at it and let's see what happens. Yeah, so if you emailed me, we can talk about it now. If you need to be in a private session, you want to wait until about the last 15 minutes of class and remind me, and I'll stop the live stream so that we can have a private session. That way other people won't be in on it. I will check the waiting room in at 2:15. Let me go to the poll. So there seems to be a request, but I've only had one person go through the poll. And for question number 2, you can select multiple options. Let me hit save so I don't lose my work, because this thing is good for forcing me to lose my work. Record attendance, section 2, and I want today. So I'll check attendance again at 2:15. So again, there is a poll. Okay, so I still only had one person, but his request was practice homework leading up to the next exam. Okay. So the next exam is going to be over chapter 3, right? So last time we left off was the middle of section 3.3, working through the homework. I've loaded the full lecture for 3.3. I don't think I've loaded the lecture for 3.4. I'll do that. If I don't do it by the start of next week, I'll just do it during class. So with that, let's go ahead and hop back to Pearson. And let's kind of keep going through. So I think we did last time we left off is question number 14. So now today we're going to start at question 15. And again, I'll check attendance in about 6 minutes. So this question asks us to determine the half-life of the substance that decays from A naught to A in time t. Okay, so they want us to find the half-life. Let's see. Usually, okay, so there's two things I want to say here. Let's get a copy of this and let's take some notes. Ooh. I am feeling the burn. Sounds like we got a new secretary. All right. Okay. So here we're asked to determine the half-life of a substance that decays from A naught to A in this time. So now there are two ways to do it. In the chat, if you let me go to the chat. No, I don't want to stop canceling. Just in the chat. Hello. Yeah. Sorry. Do you want to see the short? I'm going to do the long way first. There are two ways to go about this. I think there's a shortcut and a long way. Let's do the shortcut first. So it says determine the half-life. So whenever I see half-life, I have this urge to always start with the half-life formula. So let's do over here. This will be our half-life track, right? And let's do. Right. So this will be half-life. Okay. So now the half-life formula, I'm under the impression that it's what I remember it as KT equals the natural log of 2. Oops, natural log of 2, right? So then if they want us to, it says find the half-life. So the half-life is the T in this formula. Did they give us the rate? See, and so they did not give us the rate. All right. So we can't just automatically start with this. If we wanted to find the half-life, if we knew the rate, we could start here. But because we don't know the rate, that means we need to use the exponential decay formula. All right. So we'll go on this other side and we'll use exponential decay. All right. Exponential decay is similar to PERT. It's going to be A of t equals A naught E. Let's see. It's KT, right? KT. Right. It's similar to PERT. Okay, so let's plug in what we were given. We were given that A naught is 10. So here, I'm just gonna let this be so I can keep track of my equal sign, right? Basically what we're doing on one side, we're doing on the other, right? And again, we're gonna just kind of work on let's use this color. So we're just gonna work on the left. This is basically based on the equal side. This is the left side, this is the right side, all right? So this is just so I'm clear about when I say this is all based on the equal sign. Okay, so let's plug in what we have. Okay, let's see. Okay, it says if we want the half-life, that means we want to finish with half of what we started with. So if we're going to finish with half, do we know A naught? Okay. Okay, so we're not there yet. So we got to go back. So then if we plug in what we're given, it says that based on what we're given, the final amount was 3.4, right? So again, we're just plugging the data into the exponential decay formula. The starting amount, which is A naught, is 10.4 e to the, and our k, we're trying to solve for k because we don't know it. And the time is 15 hours. So this is going to be 15k. Okay, so this at this point on the right hand for the exponential decay track, we know all the variables except for the rate. So we have one equation, one unknown, so we can solve, right? So to solve for k, we're gonna isolate k. We're gonna move things away from k, right? So first we're gonna start with with this 10.4, right? We have 10.4 times this guy. So if we want to move the 10.4 to the other side, we need to use the inverse operation, the opposite operation, right? So what's the opposite of multiplication? What's the opposite of multiplication? The opposite of multiplication, hopefully, you're thinking division, right? So we're going to divide both sides, the left and the right, that blue left and that right, left side of the equal sign, right side of the equal sign. We're going to divide both sides by 10.4. A number divided by itself is 1, right? So then we're just going to leave that as 3.4 over 1 over 10.4, okay? So then, now to get here, let's just go ahead and write the next part. So if we bring down our equal sign, I'm just going to leave this as 3.4 over 10.4, just to leave it so it's exact. As we work these questions, you don't want to round into the end. If you crunch a number early, then you need to write out the long decimal. Because if you start rounding early, it's going to throw your final answer further and further off, and you won't be able to round at the end properly. So you want to keep it as exact as possible until the very end. Okay. If you do crunch a number early, you have to write out the whole decimal for it to work properly. Okay. So on the right, we're left with e to the power of 15k. All right. So now if we're trying to solve for k and we want to get this k out of the exponent, can anyone tell me what do we need to do on both sides? What's the inverse of exponential, right? How do we get rid of that exponential? We have a very intimate audience. I'll log them in momentarily as soon as we finish the question. So to get this out of the exponent, we take the natural log on both sides. We take the natural log on both sides, right? So natural log, on the right-hand side, these guys cancel each other. On the left, that's what we have, right? Let me extend this. Let me extend this one. Okay. So now at this stage, if we bring down our equal sign, on the left, we have the natural log of 3.4 over 10.4, okay? On the right, we have 15k. Again, now, if we're just trying to isolate the k, if we have 15 times k, then the inverse of multiplication is division. So we're gonna divide both sides by 15, right? These cancel, so then k equals this thing on the left, right? That's gonna give us our rate. That's gonna give us an exact number for our rate. So then if we want the half-life, now we're ready for the half-life formula, right? So if we want the half-life, we can use the half-life formula at this point, because now that we have our k, we take that k and we plug it into the half-life formula. So then our half-life over here on the left, that's going to be this t, right? Is going to be equal to the natural log of 2 divided by k. And then let me kind of be consistent. So we got our half-life formula. What I want, these guys and this. Let's copy, paste, and actually let's put that there. Let's put this here, left and the right. Okay, this is fine. I'm just being a little meticulous, that's all. Okay. Is it crooked? Okay. All right. So again, we're just applying the half-life directly. Did I get it? No. Okay. So where that we have the kt equals the natural log of 2. Again, our half-life is basically going to be the t from here. If we divide both sides by k, we get this, right? So then, now we take that k that we just found and we plug it in. So again, that means our half-life is going to be the natural log of 2 divided by, we got this natural log of 3.4 over 10.4 over here. Let's do it like this, over 15. Let me just kind of rearrange this so it looks more presentable. So then our half-life is going to be basically 15 times the natural log of 2 over 3.4, 10.4, and the natural log of this guy. All right, so basically we had a number divided by a fraction. So in this instance, where we have a fraction within a fraction, we can use keep, change, flip. That's how I got to this final line. So then the half-life, this is an exact representation of it. And then once we put it in the calculator, we can get an approximation. Now we're ready to get an approximation. Okay, that's clear. So then we're going to say 15 times the natural log of 2 divided by the natural log of 3.4 divided up 3.4 divided by 10.4. Okay. Okay. Let's give this a go. Let me see. Oh, you know what? I think I forgot exponential decay right here, negative, right? Because we're doing exponential decay. Let me see if that fixes the sign. So if we introduce that negative, that makes this negative, that makes this negative, that makes this negative, that makes this negative, which ultimately makes this negative, and then this negative, and then now we get our final result to be positive, right? Because again, we can check it. If we just recall what we had and put in a negative right here, the final result is going to be positive. Yeah. All right, okay. And then so we got approximately, and it says round to 1 decimal place, so 9.3, right? So then we get 9.3. Okay. So let's see how do we do, and then let's check attendance. So then here, not this one, we want this one. Come on. Okay. We got 9.3. Okay. All right, let's take a moment to get caught up on our attendance. Let me stop sharing the screen for a split second. Okay, cool. Just long enough to take attendance. That's fine. Let me see. One more. Okay. Let me hit save. Record attendance. This section, and we want today. Next, okay. Cool. Did I get him? I think I got him. Okay. All right, and we're gonna go back. So welcome, gentlemen. Oh, let me see. Share the screen. Start the broadcast. All right. So we just finished that one. So we're just continuing with the homework where we left off from last time. If you're just joining us, let's keep it moving. If you're just joining us, also let me see. Just a few reminders. I mean, this is the things I'm going to say are in the recording when I'm saying it anyway. We got exam 2 that's coming up, right? I think there is an active poll on Zoom right now, so it's a good idea to just go ahead and take that poll so I can get a sense of how people are feeling and where you guys are at. So just check out the poll. Also, like just as a reminder, the intent of the setup of this, the way I run my class is with this asynchronous or asynchronous. The intent is for class time to be a Q&A, right? It's a time for us to be together in the same space at the same time. if you'd have asked me questions. I actually had a student in my 10 a.m. that took advantage of it. He was like, hey, could you look at my exam one? Several of the questions I submitted were correct, but he marked it wrong. And so right there on the spot, I pulled it up and I checked it. And yeah, what he was saying was correct. So I just gave him credit and they bumped him by a whole letter grade. And so he was just typing his answers in, the final answers in the wrong way. But what he had was correct. And so, but he took advantage of it. Now, again, I do encourage you to email me just so it's on file and it's on record. But I'm going to be honest with you, it's a good chance that I probably won't see it. Or if I do look at it, it might be like towards the end of the semester. Like I'm just not going to check them, right? And so the real intent is for class time to be office hours. So if you have questions or if you need things that need to be resolved, the best time is during class. Is to ask me. I'll stop and we can talk about it. Else I'll just, and I kind of just go through the homework because it's kind of a challenge to get students to engage and talk and speak up and stuff like that. So I just fill it with the homework. And you can actually use these recordings as you work on your homework. It's going to be the same questions. It's going to be the same questions with different numbers, right? So a lot of times the exams are similar. But I think I did include like maybe some questions that were not in the homework that's on your exam, but it's the same concept, right? So yeah. So again, we have exam 2 coming up during week 8 over chapter 3. And then after that exam, we're going to spring break. So we're off for a week. Okay. Let me check Zoom one more time. The chat looks good. Waiting room looks good. Okay. So let's go ahead. We only have a few more questions. We'll see what it looks like, but how much time we have by the time we finish, and we'll make a decision there. So this one asks us to assume the exponential growth model of this and a world population of this into 5.5 billion in 2004. If the population must stay below 24 billion during the next 100 years, what's the maximum accepted annual growth rate? This is interesting. Okay, so let's get a screenshot. Let's take some notes. I think we got this one. Anybody feel confident to approach this one? Want to give it a go, or either walk me through it? Let's see. Oh, come on. Boom. Okay, I can click over. Okay. Oh, okay, that's fine. I'm gonna let that be. Okay. Okay, so it says that we're starting, let me see. So we're using the exponential growth model. So let's go ahead and get a copy of that. So we have this A of t equals A naught e to the kt. Okay. Now it says the world population of 5.5 billion in 2004. So we're gonna let 2004 be our starting year. We're gonna let 2004 be year 0, right? And so what that means is our starting amount for year 0 is what, 5.5 billion. Okay. If the population must stay below 24 billion, so we need A of t to be below 24 billion. And so in the time, the given amount of time is 100 years. Like Avatar the Last Airbender. How many of you guys know about Avatar the Last Airbender? I'm definitely showing my age with that one. The time is 100 years. Just a moment. Okay. All right, so this is the information that was given. 5.5 is the starting amount. For the next 100, we want the final amount to be below 24 billion, and then the amount of time is 100 years, right? What is a maximum accepted annual growth rate? So we're gonna say they're asking us to find the maximum K. Okay. Let me see. So the final amount, and here, let's do this. Let's do our left and our right. I just feel like that helps with the organization. So like our equal sign goes here. And this is just something, I saw someone do it a while ago. And I just feel like it helps organization. Okay. And we can start here. Let's start with our given formula. So we have this actually, I'm going to put my A of t on the right-hand side. So over here on the right, we have the final amount, and we want the final amount. We want this A of t. Sorry, that's not the right way. We want the final amount to be below 24, right? So let's do it this way. Let's do this. We'll put you here. We want the final amount to be below 24 billion. Okay. All right. So we want the final amount to be below 24 billion. So then, and this is actually going to be A of 100. So after 100 years, the final amount after 100 years, we want it to be below 24 billion, okay? So then A of 100, so the starting amount is 5.5 billion. So we're starting with 5.5 billion times E. We don't know K, so we're solving for K. And the time is 100 years, all right? So 100 times K. Okay. And again, we want that to be less than 24 billion. Okay. This is what we're working. So now we can just do the algebra. If we want to solve for K, inverse operation, right? Let me see. So first, what? Divide both sides by 5.5. A number divided by itself is 1. I'm going to leave the right as is. And then to get that out of the exponent, we take the natural log. Let me just rewrite it. So E to the power of 100K, we want that to be less than 24 over 5.5. And again, to get that out of the exponent, we take the natural log on both sides. So natural log of this, natural log of this. Natural log is the inverse of exponential. They're gonna cancel, and this is gonna come out of the exponent. I'll continue here. Copy, paste. So then we bring down our inequality. On the left, we have 100K. On the right, we have the natural log of 24 over 5.5. Okay. So then the inverse operation, we have 100 times K. So then the inverse of multiplication, again, is division. Divide both sides by 100. All right. So then K needs to be less than whatever that number is. Okay. So then we're going to say, come on, the natural log 24 divided by 5.5 divided by 100. So looks like it's 1.4%. Let me see. Round to the nearest 2 decimal places. So again, this is already in decimal form, so they wanted the final answer to be as a percent. So when we put it in the calculator, again, we got 0.0147. I'm just going to do 33, so on and so on. To convert this to a percent, This do I to move the decimal to the right by 2, so this is going to be 1 point, and I think it said 2 decimal places. 2 decimal places. So then 1.473. So that 3 tells the 7 to stay. So 1.47%. Okay. Let's see, how do we do? And again, if anything is not clear, you have to speak up. If you don't say anything, then I can't help, and I can't make you do anything. You have to decide yourself. Okay. Okay, we got 1.47. We want this one. Okay, go. 1.47. Let's see, how do we do? 1.47. Okay. Let me check Zoom really quickly. Okay. All right. So with that, there is nobody in the room, so there's no need for me to keep going. I mean, I guess I could stream it, but it's not necessary. I could do the rest of these, but since nobody is requesting it, I'm not going to bother. And on that note, we're going to end this recording later. You know how to find me. I'm available. Yeah. And again, so our exam 2 is going to be over all of chapter 3. It'll be, let me see, this is what, the end of week 6. So I think that exam is during week 8, right? So we have all of next week, the week after next, that's when the exam is going to hit. So if there aren't any burning questions, we're going to end the session there. And from one beautiful mind to another, enjoy the rest of your day. Okay, take care, guys. Peace.